Hello, ladies and gentlemen. Welcome back to math. Today, we are going to learn about exponential functions. Okay? You might ask yourself, what are exponential functions? Exponential functions are, okay? We kind of cover something similar towards the beginning of the first semester. Okay? If you're new to this class, it's okay. Okay? I'm going to go a quick little review of what it is before we start on the concept. Okay? So, the first part, exponential, means something that expands. Okay, exponential says that in the name. Okay, expands. Think of a sponge. When you put it in water, it absorbs that water, right? It expands, becomes bigger. Another example is I have this die, okay, that I bought. I haven't opened it yet, still in the plastic, still in the wrap. But once you fill it up with air, it expands, right? It becomes bigger. For example, I have one that I already filled up with air, okay? So it went from this tiny little thing to this expansion, okay? So it got bigger, right? That's what the first part of the equation is, okay? Something that is going to expand. A function, on the other hand, because remember, it's an exponential function. A function is, we get our vertical line test. Okay, this is my pencil. Okay, we draw a line, some lines, and some shapes. Okay, we're gonna do the vertical line test. Okay, see if it's a function. So this first one, we get our pencil, we do the vertical line test. Notice that throughout the whole test, okay, it only touched once, okay, throughout the whole line. That means that it is a function, okay? When it's not a function, think of a zero, okay? When you start doing the vertical line test, notice that you're already touching here on top, and you're touching on the bottom at the same time. That is not a function, okay? In order to be a function, it only has to touch your vertical line test only once, okay? Now that we know what exponential functions are, okay? So a function that expands. When you have an equation, okay? Today's equation is going to be y equals ab to the x power, okay? You might look confused right now. It's okay, okay? Yes, they're not numbers right now because this is the original equation, okay? The way you label it is ab to the x power. For example, if I were to write on the board y equals 3 parentheses, because we have another number next to it, 5 to the 4th power. Okay? Probably should have written it a little bigger. Let me write it a little bigger so you guys can really see it. We have y equals, again, 3, 5 to the 4th power. Okay? The first number in this equation is a. Okay? That's what I mean with the equation y equals ab to the x power. The first one is a. Your second one is b. And hint, hint, what is our exponent? Anybody? It's x, right? So our exponent is x. Now that we know how the equation works, okay? So no matter what numbers you have in here, you still have a, b, and x, okay? Make sure you write everything I read on the board down for your notes, okay? Now that we have that, now that we establish what the equation is about, we can actually do some assumptions about it, okay? First things first, in order for an exponential function to actually be a function, a cannot be 0, okay? It has to be bigger than 0, okay? If it's 0, it's not a function, okay? If it's something smaller than 0, meaning a negative number, then it's just a horizontal line, okay? It has no growth, no decay, okay? If it's just anything below, okay? B has to be bigger than 0, okay? But B cannot be 1. So it has to be everything over 1, okay? It can be 3, it can be 2, it can be 5, it can be 1.5, because it's bigger than 1, okay? Anything that is bigger than 1, and it's a positive number that is 1 or above, it is a function, okay? If it's anything below 0, okay, it's just a horizontal line, okay? If A is -1, -5, there's no function because it's just a straight line, okay? In order to find out if our equation, okay, it's going to have exponential growth or exponential decay. When it comes to your mind decay, you might ask yourself, like an apple, when it over time starts going nasty and starts decaying, not that kind of decay, okay? Our kind of decay is negative numbers, okay? And then in a graph, when it goes down, exponential decay. So if you have a graph and our line goes down, it's an exponential decay. If it goes up, it's an exponential growth, okay? How do we know this? How do we know the difference between decay and growth? For a growth equation, A has to be bigger than 0, okay? B has to also be bigger than 1. So, for exponential growth, if we have any numbers, we can think of any numbers that are A is bigger than 0. For example, we can say Y equals 1, parentheses, 3x. Okay? Again, if we label it, we have A and B. And then x is just x in this equation. But A, remember, in order to be an exponential growth, A has to be bigger than 0, which it is, right? It's 1, so it's bigger than 0. Is B bigger than 1 in this equation? It is, right? It's 3. So this is an exponential growth. It means it's going to get bigger. Okay, it's going to go to positive numbers. For exponential decay, on the other hand, you're going to go into negative numbers below. Okay, you're going to go, think of the sea. You're on the flat surface of the sea, just chilling there. Okay, just minding your business, and then you decide to go on a plane. Okay, there's some planes that land on the water. You get on that plane and you get higher from the water surface. Okay, that's the growth because you went from the sea level, you went up. For decay, think of scuba diving. You want to go scuba diving, so you go underwater, right? Now you're under. Okay, that's negative, so it's a decay. But in order to find out if your equation is a decay equation, okay, A, it still has to be bigger than 1, because remember, if it's negative, it's just a straight line. It's not a function, really. Okay, it has to be bigger than 0, but it might look a little confusing, okay? B has to be bigger than 0, but smaller than 1, okay? That means that if our equation for the decay, we have y equals, because remember, it still has to be positive, your a. Let's say 2.5 for b to the x. That means it's going to decay, okay, because of the 0.5, because your b is in between 0 and 1. Also, if you had, instead of 0.5, you had 1/4, it's still less than 1, but bigger than 0. 1/2, even 0.75, okay? Like I said, anything in between 0 and 1 for b, as long as a is positive, okay, and it's bigger than 0, you're going to have an exponential decay, okay? So, the only difference between them, exponential growth and decay, your a is still the same. Your a on both of them has to be bigger than 0. But to know the difference between them, it's your b, okay? If b is bigger than 1, then it's an exponential growth. If b is in between 0 and 1, okay, it's an exponential decay. I mean, did I say growth here, decay here, okay? All right. So for your assignment for today, okay, are you guys ready for it? Yeah? All right, make sure you write down everything, all right, on your notes, everything I wrote on the board. All right, so now do you have it on your notes? The assignment for today is, all you have to do is tell me if the equation I'm going to give you, if it's going to have an exponential growth, exponential decay, or neither. Okay, hint, hint. Remember, a neither is when a is less than 0. Okay? So for your first example is y equals 0.5 parentheses, for b is going to be 2 to the x power. Okay? For your second one, y equals negative 2.8. Our b is going to be 2 to the x power. Okay? And finally, for the last one, we're going to have y equals 1.1. Our b is going to be 0.5 to the x power. Okay? Hint, hint, guys. I used one of each, okay? I made it a little simpler for you. Pretty much gave you part of the answer, okay? In a way. Because remember, I used one for positive, one for growth, one for decay, and one for neither. All you have to do is find out which one's which, okay? All right. As soon as you're done watching the video, submit your answers, okay? I'll be waiting for your email.